In this video, I am going to solve these three questions, which is taken from the chapter 4, titled Motion in 2 and 3 Dimensions. And these questions are taken from the book Principle of Physics, 10th edition. Let's start the first question. An electron position is given by r vector, which is equal to 3t I cap minus 4t square j cap plus 2 k cap. So first of all, I have to write the equation, the position of the electron, which is given by r, which is equal to 3t I cap minus 4t square j cap plus 2 k cap. With t is in seconds and r is in meters. And this question has four subdivisions. In the first part, we are going to find what is the electron velocity in vector notation. That is our first question. In the second part of the question, we are going to find the electron velocity at a time t is equal to 2 seconds. In third question, we are going to find what should be the magnitude of the velocity. And fourth questions, we are going to find the angle. Clear? So we will start, we are going to work out one by one. So first of all, I have to find what should be the electron velocity, and here the position of the electron is given in terms of vector form. So we have to go for the instantaneous velocity. So what's the formula for instantaneous velocity? Instantaneous velocity, which is equal to d of r vector over dt, which is equal to d over dt of r vector, which is 3t I cap minus 4t square j cap plus 2 k cap. Now I'm going to differentiate this equation with respect to time. So we have to use the equation n x power n minus 1. I'm going to apply this rule for each t value. So by that, we will get the answer of the instantaneous velocity. So therefore, v vector, which is equal to, first I'm going to apply this rule here. So here the power of t is exactly 1. So what will be the answer? 3 multiplied by 1 t power 1 minus 1 I cap minus 4 is the constant. And what is the power of t? So 2 t power 2 minus 1 j cap. Here there is no t value. So if you want to differentiate with respect to time, it will give you 0. So now I have to work out this equation. So what will be our final equation? V vector, which is equal to 3t power 0. So 3t power 0 is nothing but 3 I cap minus 4 multiplied by 2 gives you 8. So 8t power 1 value. So 8 t power 1 is nothing but, I'm not going to write anything, because if nothing was there, it's indirectly says the power of the t is 1 j cap. Clear? So this is the answer for the first question. In the second part of the questions, we are going to find what should be the electron velocity at a time t is equal to 2 seconds. The time t is equal to 2 seconds. So for B part, we have to use the time which is equal to 2 seconds. So I have to substitute the value of 2 here. So by that, I will get the answer for the second part. So therefore, V vector at a time t is equal to 2 seconds, which is equal to 3 I cap minus 8 multiplied by 2 j cap. So the final answer, V vector, which is equal to 3 I cap minus 16 j cap, and the unit is meter per second, and here also the unit is meter per second. Clear? So this is the answer for the second part. In the third part, we are going to find what is the magnitude of the electron velocity. So we have to consider this equation. So the magnitude of this electron velocity, which is equal to square root of This is our x value, this is our y value. So 3 square plus minus 16 square gives the answer of, this is 9, and then what is the value of 16 square? 16 square is 256 plus 256. So 256 plus 9 gives 265. So square root of 265. So square root of 265 gives the answer of 16.27. What's the answer? 16.28 meter per second. Now, in the fourth part, we are going to find the angle. As we already studied the formula for finding the angle, theta, which is equal to tan inverse of y component over x component. So here our y component is minus 16, our x component is 3. So what should be the answer? So tan inverse of our y component is minus 16 and our x component is 3. So we have to find the value of the theta as tan inverse of minus 16 over 3 gives me the answer of minus 79.38 degree. Clear? So this is the answer for the fourth part. So before you answer the question, you have to read the questions very carefully. Clear? So first try to identify what is given in the question, and then please use the concerned formula for that question, and then try to work out very carefully by using your calculator. Clear? Second part, second question is related with some football. So what is given in the question? A soccer ball is kicked from ground with an initial speed of 21.3 meter per second at an upward angle of 45 degree. So here a player is going to kick the ball with an initial speed of 21.3 meter per second at an angle of 45 degree. So opposite to the player, another player was exactly 55 meters away from the point of kick, and he is going to take that ball. So once the first player start kicking the ball, the second player at a distance of 55 meter, he is going to take that ball. So for that, he has to come with some particular time. Am I right? So that means the kicking part, the parabolic time, which is exactly equal to the time the second player is going to take the ball. What must be his average speed if he is to meet the ball just before it hits the ground? Actually, this question is related with a projectile motion, and here we are going to calculate what should be the average speed of the second player. So the first player is going to kick the ball and the second player is going to take the ball. So what is the question? So the question tells about what should be the average speed this player should take before the ball touches the ground. Clear? So we first of all, we have to write what is given. So what is the initial speed? The initial speed here they mention 21.3 meter per second, and the angle of kicking, which is exactly 45 degree, and the distance of the second player from the point of kick from the first player is exactly 55 meter. And by using these things, we have to find what should be the average speed. So before we substitute all these things, better we can just draw the diagram which is related to the question. So I'm not a good artist, better I try to draw the diagram for this. So this is the ground, and here a player is going to kick the ball. So this is our ball, and when he kick, what will happen? It will go like a projectile motion as a parabolic trajectory. Clear? So before the ball hit, and the another side, another player is going to take his ball. Okay, so that means another player is here, is going to take the ball. So that means that he is coming with some speed, am I right? So the distance and the angle of kicking. So here the initial velocity, the player is kicking with 21.3 meter per second, which is our initial speed. And what is the angle? Theta, which is equal to 45 degree. And the most important thing, the distance from the first player to the second player, here they mention as d, which is equal to 55 meter. Now we have to find what should be the average speed of the player to take this ball. So now the most important thing, we have to use the concept of projectile. So what is the formula for finding the average speed? For finding the average speed, we need distance over time. Am I right? So here we have a caps D. So I am going to make a small d for the distance. So distance over time. Clear? Now you have to see the distance is very, very important. Which distance? We need this distance because he is going to take the ball. Clear? And then time we have to find. So what is the time? The time taken by the ball for a complete parabolic trajectory, which is exactly equal to the second player is going to take the ball. Both times are exactly the same. Then only he can take the ball from the first player. So if you want to find this distance d, small d, first of all we need the value of range. Am I right? So once you identify the range minus this distance d, caps d, gives you the value of small d. And also we have to find what should be the time of flight. So this time of flight, which is exactly same for this player to run to take this ball. So these two things we need. So better in place of small t, I can put caps d. Okay, that's the very, very important thing. So now, first of all, if you want to substitute the value in this formula, we have to find the range. From the range, I'm going to subtract this caps d. And when we subtract the value of the caps d from the range, we will get the small d. Clear? So I'm going to work out step by step. And we already studied the formula. What's the formula for the range? The range formula, which is equal to v naught square multiplied by sine 2 theta divided by g. This is the formula for the range calculation. And what is the magnitude of the initial speed? 21.3 square multiplied by sine of multiplied by 45 divided by 9.8. Now here you have to see, when you multiply 2 multiplied by 45, you will get the value of 90. Sine of 90 is maximum, which is equal to 1. So you will get only 21.3 square multiplied by 1 over 9.8. So that will give the range value of 21.3 square over 9.8. So the answer is 46.29. So the range R, which is equal to 46.29 meter. Now we can easily find the value of the small d. How we can find? So if you want to find the value of small d, we have to subtract the caps d with the range. So what is our caps d here? 55 minus what is our range? Our range is 46.29. So 46.29 gives the value of the distance taken by the second player. So 55 minus 46.29 gives the answer of 8.71. 8.71 meter. So that means the distance this small d is 8.71. So that means we found the value of small d. The only thing we have to find the value of the total time of flight. So the total time of flight, which we can find from the formula of t. What is this t? For example, you have to see this. If any object is going like a parabolic trajectory, the object will reach the maximum time, maximum height. Am I right? So this is the time, small t, and the second part of the curve is also small t. So what is the total time of flight? The total time of flight is 2 times of t. So now in the second part, what we are going to do, we are going to find the value of t, caps t. So for this, first of all, we have to identify what is the value of small t. Okay, so for small t, we already have the formula v naught cosine theta over g. So this is the rule. So what's the value? So v naught value here is 21.3 multiplied by cosine of 45 degree divided by g value. What's the value? 21.3 multiplied by cosine not cosine, I think this is sine, because the time of flight which comes in the sine value. Am I right? So here I have to put sine, I think so. Clear? So sine of 45 over 9.8 is 1.53. So what's the value? 1.53 seconds. So better I can write 1.54. So this is small t. So what's the total time of flight? 2 times of t. So which gives you the answer of 2 multiplied by 1.54. So 1.54 multiplied by small t gives the value of 3.08. So the total time of flight, the ball take as 3.08 seconds. Now we got both answer. So now we can directly go for finding the value of average speed, which is equal to distance over time. So what is our distance here? In the first part, we found the distance as 8.71 meter. 8.71 meter divided by 3.08, which gives the answer of 8.71 over 3.08, which is 2.82. 2.827 we got. So I'm going to write 2.83 meter per second. So here the final answer speed, which is equal to 2.83 meter per second. Clear? So first please try to understand what is given in the question, then only you can easily, first of all, please write what is the formula. From the formula you can easily understood what are the things you have to find. Clear? And here we use this formula for finding the range, am I right? But we have another formula also, am I right? What is the another formula for the range? R. You can use range, which is equal to v naught cosine theta multiplied by caps t. So here v naught is 21.3 multiplied by cosine of 45 degree multiplied by the total time of flight. What is the total time of flight here? 3.08. 3.08. You'll see, you'll get the same answer like this. 21.3 multiplied by cosine of 45 degree multiplied by the t total time of flight is 3.08. So you got the same value, 46.38. See, closer to each other. So if you take for 46.3, here also it is 46.3. So you will get the same answer, because here I just rounded the value to 1 digit, and if you rounded this value to 1 digit, you will get the same answer. So either you can use this formula or this formula, both will give the answer. Clear? So in this way you have to solve the this question. Actually this question is from chapter projectile motion, and you have to deal with a lot of formulas in this chapter, so please stay strong in the formula. Clear? And here the time is not cosine, because the time will take only for the vertical component, because the x component is related with cosine, because the time of flight is only taken in the y component. So initially I made a mistake here to write cosine. Actually this is sine theta. So last question. Read the question carefully. A rotating fan completes 1100 revolutions every minute. So that means you have a fan which rotates every minute. It is making a revolution of 1100 revolution. So that means better I can write the fan. So if you take a fan, so we have fan, and this fan is rotating. Am I right? So for every minute, it completes the revolution of 1100 revolutions every minute. So every minute they make 1100 revolution. Consider the tip of the blade at the radius of 0.15 meter. So it's like so its radius is given, which is 0.15 meter, and then how many revolutions it made? It made 1100 revolution in every minute. It means for every minute. First question, through what distance the tip moves in one revolution? So if the fan want to complete one complete revolution, how much distance it will be covered? It is nothing but the circumference of the circle. Am I right? So here the distance covered by the fan tip for one complete rotation is exactly 2 pi r. So 2 multiplied by pi multiplied by the r value here is 0.15. So what will be the answer? 2 multiplied by pi multiplied by 0.15 gives the answer of 0.942. So the distance for one complete circle on rotation is 0.942 meter. Clear? In the second part, we are going to find what is the tip speed. So what is the tip speed? So we have to use the relation of rotations, the linear speed with the angular speed, v, which is equal to r omega. But here the omega information is not given, so better we can just go for the time. So in this question they mention every minute the revolution is 1100. Am I right? So what's the time? The time which is equal to every minute, which is nothing but 60 seconds. For every 60 seconds, how many times it's rotate? 1100 times. So what's the answer? 60 divided by 1100 times, which is 0.054055, because 0.0545 it came, so I am going to write. So this is the time, and by using this, actually this is our first part, and by using this value of the time, I'm going to find the answer for the second part. As we already know the definition for finding the speed which is equal to distance over time. What is the speed? Speed v, which is equal to distance over time. What is the distance here? I'm going to take the answer from the first part, which is 0.942, and the time is 0.055. So what's the answer? 0.942 divided by 0.055, which is 17.12. What's the answer? 17.13. 17.13 I got. Speed which is equal to 17.13, and the unit is meter per second. In the third part, we are going to find what should be the magnitude of its acceleration. And this object is rotating because the fan is under rotation, so that means we have to use the centripetal acceleration, which we studied in chapter 4. Actually, this chapter we studied the formula for centripetal acceleration, A of C, which is for centripetal acceleration or radial acceleration, which gives the rule v square over r. This is the rule. So what I'm going to do, I'm going to take the answer from B part. I'm going to substitute here. So 17.13 square over, what is the radius of the fan blade? Is exactly 0.15. 0.15 gives the value of 17.13 square over 0.15. So 1956.2. 1956.2. I can write these as centripetal acceleration 1.95 multiplied by 10 to the power of 3 meter per second square. Clear? The fourth part, what is the period of motion? Actually, the period of motion we already found. The period of motion already we found, but anyhow, we can use the same relation of the B part. What is our answer for the B part? The B part we are using the formula V, which is equal to distance over time. Therefore, the time period, which is equal to distance over speed. The distance we found here as 0.942 over, what is the speed? 17.13. When you work out this number, you will get the same answer like what we got here. So let's check. 0.942 divided by 17.13 gives the same answer. 0.055 second. Clear? So we can cross check our answers. So the first part, when we calculate the time period for every minute, because every minute the blade having 1100 revolution. So for 1 minute we calculate the time period. Am I right? So this is the time period. So now our answer exactly match with this. So that means the calculation in the calculation of the time period, our calculation was perfect. Clear? So if you want to answer this question, please first of all read the question at least twice the time. First of all, try to understand what is given in the question, and then please try to find what we need. Clear? And read the questions, because some question has the subdivisions. You have to read very carefully, and then please write the concerned formula for that question and apply the value properly and try to get the correct answer. Understand? Thank you.